Oh, I don't see Bernard. Oh, Bernard is here.
So we usually have an intro from you and then some same related topic talk. So do you have any intro about Fluence, something?
Actually, I have some connection issues. I can cut off at any moment. I don't know. Like, I mean, Valery, you can start if you want, or if anyone wants to. If anyone has anything urgent, don't hesitate to share. And I guess the plan is, as at previous calls, we're gonna have some talk about one of Fluence components by the Fluence Labs team, and then Q&A and whatever everyone has in mind. All right.
All right. So let me start. Today I will talk about Marine. It is our WebAssembly runtime, which we use to run services in the Fluence network. It runs the services and it runs the AquaVM, which interprets all the Aqua code. So today it will be not the talk about internal implementation or something, to do like a demo. Like I will create a service using all the tooling we have and show it to you, describe the experience and the tools I will use. So let's describe what let's then just start going to the IDE. I'll share my screen. Great. Do you see?
Yes.
Yes.
Great. So
you maybe can zoom in a little bit, but
zoom.
Yeah, zoom in.
What?
Like
zoom.
Make the fonts bigger.
Make the fonts bigger. Oh, okay. Does it work? No. So.
There's presenter mode.
Okay.
It's the simplest way.
I don't see the
in the view
difference.
Or triple shift. You can press triple shift and then presenter mode.
Triple shift, presentation
mode.
Thank you.
Oh, and something else after that.
Something else.
So it wasn't the best advice, probably.
You should run enter presentation mode.
No. That's not the thing. And it's not what I wanted.
Exit presentation mode.
Yeah, there was exit presentation.
So let's just make the fonts bigger.
Yeah, maybe that's fine. Maybe just
fonts are completely fine for me.
Let's make it like 18. Would be better, maybe. But I'm looking at my 13.
Press apply close the window and go ahead.
Okay. What?
Probably it should be in appearance.
Let's start without it. I think we just will spend time doing nothing. And do anyone want the font to be bigger? Actually,
For me, it's nice. I think Evgeny can survive.
Yeah, I will survive. Yeah. Sorry.
yeah. Okay. So imagine we want to have a service which will download something from the network, then save it on the disk, on the file system. So it is a simple example which already can be split into some modules, into some parts. So we want the service interface to be some function. I will write it in Rust, like let's see at the interface I want to implement. It can be just rel in the form of string, and some file name in the same form to store it here. So let it be the service interface, and we can split the service in several parts. We can create a part that goes to the network, create a part that goes to the file system, and the part which composes them, and does of the it provides the interface of the service. So main is the so let's see how can we divide it. We can create a service, the model that goes to the network. Let's call it serial adapter. Let's have a model that goes to the file system. Let's call it storage. And the model that composes it and provides interface, let's call it facade, as it the model that looks into the outer world. So what interface can we provide provide from such models? Like serial adapter can provide a function download, which will take a URL and return something. We don't think here about error handling and anything such. So let's assume that anything always returns the result and so on. And storage can go to the file system and save the file. So it will have the function like store, which takes file name and some content. Okay, it doesn't have to return anything. And let's have the function facade that we already described. Let's go to facade. So, and Marine allows us to implement everything in different modules, then link it and run as the one. So let's start implementing. I will start with a C URL adapter. Okay. Let's create a array. Okay. Let's add it to the workspace. So we have the same target directory for everything. Okay. And we need to add the Marine Rust SDK as a dependency. So we can write our model. Okay. And we can start writing. We usually need the main function as runtime calls it when it needs to initialize some of the functionality. So let's keep it empty. There, we need to write a function that, as we described, does the download thing. So let's see how we implement it. We need to wrap it with the Marine macro in order to tell tell our runtime which functions we export to the interface. So let's wrap it in the Marine macro. And let's just try to return something. Don't go to network. Just make some string. And let's see if we can compile it. We use the macro from the Marine SDK. So, okay, we have the dependency, we have the Marine macro, and we have a function. Let's build this crate. We have the Marine build helper, which distributes in cargo, which can be downloaded by cargo like this. I already have it, so I don't need it to install. So let's try to build our module. Let's boot and release. We don't need the debug. So it will download all the dependencies of the Marine Rust SDK, and at an end will build the service. So we build it. Okay. Then we may want to try to call the function and look, does it work? Does it work? To create a service, actually, we need a config that tells which modules are in the service. So we create a file. So we create a file. Let's call it config.toml, as it must be in the toml format. So we need to tell where are our modules, and they are in the target directory. So I think I didn't add the project to the workspace. I forgot to do it. So let's build it again. It will create a WASM, that's it, to WASI directory in the target directory. So there will be our WASM file. And we can provide this path to the config file target, then WASM to WASI, release, and so then we need to provide we need to tell the marine which modules are in the service. So we need to create a module part and name the module. It will be the name of the WebAssembly file, like this serial adapter. So okay, then to test our service, we can use the marine REPL, in short, mrepl, the CLI tool to inspect the service and modules. So it can be installed as marine by cargo. So let's look at this service. Provide here the config file. So the service is loaded. We have some instructions here. They are pretty simple. Now we need the interface instruction to look at our module. So it loaded one module, serial adapter, with the function load, which takes string and returns string. And you can call it as the marine REPL has the marine runtime inside it. You can use call and provide the module name, then function, then argument. We don't need it actually. So we see it works. We got some string. Okay. Then we have to somehow go to the network. As you know, WebAssembly doesn't provide direct access to system interface and such things. So we need to provide some way. We needed to provide some way to access serial, for example, command line tool. So we implemented the approach we call mounted binaries. We can, in the config file, provide a section called module.mountedBinaries. Then expose some names here, like serial, and provide a path. It is a user in serial for me. So, and in the source code, we can import this command line tool as a external function. So we need to write a extern C block, wrap it in the marine, and also tell from there we need to import functions from this external model. And for the mounted binaries, it will be the host. So tell link and provide attribute WASM import. Then if we provide here the host, then we will import binaries and not functions from other modules. So here we will have a function named serial as in config, which will take a vector of strings, the command line arguments, and which will return a structure from SDK called mounted binary result. And that's it. We can the marine wraps the call to the binary from file system into the function and provides this function to the module, so we can use it in our services. Mounted binary result consists of some useful fields like return code of the program, return code of in the string form, the stdout and stdr, and so. So let's return to our loader. So and use the serial here. So now we need to use URL. The ID highlights the call to the serial as because thinks it is unsafe, but actually it will be wrapped by Marine when it will build project. So it will be nothing, no warnings, no errors about it. So we have the result. We don't care about errors. We think that the result is in stdout as usual. So let's create a string from the result. Let's think ZTF-8. And we can unwrap it because we don't care about the errors. So now we can think that it is ready. Let's go to the directory and build it. Oops, reverse. It is strange because we just built it without any problems, and we just declared it. Okay, let's see if we have it here. We have it here. Mounted binary result. We have it here, and I can just undo it. Okay. So it's again, and it worked. Okay, it was stranger, but it doesn't reproduce anymore. So let's test it. In mrepl, we have the same function. Mrepl stores stores input history, so we can just run the same string, and it will return nothing because test is not a valid URL or something, so it will be an error. Let's go to the, for example, google.com, and we will go some return. We didn't provide this URL with the additional flags, so it returned first result, and it was the description that you have to go somewhere. Okay, but we see that the idea works. We really did go to the network, and we got some result. Okay, let's.
Valery, before you go on, can you explain something here? The REPL, that is the actual marine runtime that's usually on nodes, yes, basically running on your local. Is that, can you like explain a little bit about that?
About the marine runtime in the mrepl?
Yeah, the marine runtime, sort of a little bit how it does, you know, how it takes the code, how it takes those modules, how it processes, and how the REPL relates to it locally to the remote or the deployed one.
We will not deploy that service here to the network. We don't need it. We just look at the tools. So about the REPL. It's just that we have a runtime as a library, and we use it everywhere when we need. And we have one difference in the interfaces of the mrepl and the node. That node has the concept of the facade module if the service consists of several modules, then node shows only the interface of the last module in the config. So for all underlying modules are hidden. And mrepl provides all the interface to all modules. So it internally, it takes some modules and runs each in the runtime in each module in the separate sandbox, and which has only interface that is given to this module. in the config, and we'll talk about it later. If the module has, if we have a multi-module service which can link, which can use, where modules can use functions from each other, there the mrepl, marine runtime in there will link the functions and structures of modules internally, and will provide the safe way for the data between modules. So the marine runtime provides that shared nothing linking scheme, so and one module can access memory of the different module in any way, unless the host explicitly given this permission in that through some workaround, like provide like memory mapping from somewhere, like it is hard to do accidentally. I don't know what you want from me more about what I can tell you right now.
So one thing you did was, over last week, you created a multi-module testing unit, right?
Yeah, I will talk about
that. And that basically allows people to test their code, their WASM modules within the Rust code, as opposed to having to do it manually in the REPL, right? That's sort of one of the updates from last week.
Yes.
Are you
it provided the way to test without mrepl, but automatically run load WASM modules into the environment, into the runtime, and use and access these functions from the Rust code for the single module. It works for the single service. We can use it for different service. I wanted to talk about it later, but I think we are short in time, so I'll try to be slightly faster this time. Okay, so we have the model which goes to the network, and we need a model that goes to the file system. So let's create it. Let's call it storage. Okay, you can add it to the workspace, and then add the same dependency here. So we not need this, and we need to add another module into our config, service config. And it will need to go to the file system. So we need to provide some interface to say where it can go, because if we don't say, it will not be allowed to go anywhere in the file system. So we use the WebAssembly system interface for it, and provide some. We can say which directories it can read. Let's say we have data dir, which will map into data dir internally. And we can pre-open it. So okay, it will. This line describes which directories we are allowed to read from the WASM. The WASI ensures that we don't read anything outside them. And this line says that says to the runtime that we want to open files in this directory and this directory before running, not lazily, but at the start. So let's use it. We can just use common file system interface from the Rust to use the file system. So summary. So fs. So path. What interface we written here? Store. Great. Let's implement the function. So we need to write some boilerplate. We need to make a full path. This will be data and file name. Then we have to create a path actually. I forgot new write choice. Okay, it may not compile because I don't remember the new or from I should use for the path. Then it will be just store, and we will just store the data we got. And unwrap it to see if there to have a panic if there was an error, and just drop the result. Okay. Oh. Let's build it. Oh, I forgot to wrap it in Marine. So okay, we built the model, and we can create directory. We can test it with mrepl. But maybe we can just they create a directory in the right place? No. No. I didn't create actually. So okay, everything is opened. We have two modules right now. We can call storage module, storage, store, and then we can provide several arguments in mrepl. The arguments are in JSON, so it is an array of two entries, two strings or objects or something. We can pass here like sub file and then some content. Let's refresh it. And we have some file with some content. So it works. Great. Then we need to wrap it into the one module, which will provide both. We need to compose it. Yes, this part. Okay. Okay. Again. So here we need to import functions from our modules. We can do it using the same pattern with extern. But this time we will provide the name of the model from which we import functions. Okay. So then we can just copy the function interface from there. There, this, and this. Okay. Then we want to import the store function from the storage module. Then we can go to the storage and store and file name and content. Okay. So now we have imported our functions, and we can write the functions, final function, download and say downloaded store finally. It will take there. And it will do the simple thing. It will download and save as expected. Great. And wrap it in marine, so it will work. So it will be in the interface. Okay. Let's go to the facade and try to build it. Great. We build it. Go to the config, add facade here. It will be last. If we deploy it to the node, then on the last module, it will be an interface. So facade must be last. Okay. Now we can use mrepl. See that another model appeared and call the function. Let's go to the google.com and store result in Google response. So I think I named it differently. Yes, download store. Okay, let's just change the name in the call. And it works. And we can see the result here. So we composed here some modules into one application, which we call a service, which could be later deployed to a node. But right now we are running out of time, and I think we will not have time enough to show the testing SDK. I'm sad about it, but that's it. We looked at the marine, which builds our models. We looked at the marine SDK, which helps us describe the interface of the model, and looked at the mrepl, which helps us test our model by hand. So I think that's it. I don't want to say anything more, but I think we will answer questions if you have any. So let's ask it in the voice chat or in the text chat, and we will help you with your questions. So I'll wait for it.
So yes, I have a question, loaded question. So in this multi-module environment,
Yes.
instead of using the REPL, we can now test or run those multi-module tests in the code, right? I mean, that's what you did over the last couple of weeks.
Yeah, we can.
And maybe, I don't know if you could just quickly bring up the marine example, the multi-module example from the repo, and just show us what it looks like on how to test those in code as opposed to interactively in the REPL.
So okay, if you really want it, I will go for it. That's clear. We created a testing SDK which takes our WASM modules. It doesn't take even code of. It doesn't need even code of the services, and it takes the interface from the WASMs and provides it to the user, runs internally the marine runtime with the WASMs, and provides Rust interface for it. So in the common Rust tests, we can write the code which will automatically run runtime and call some functions and do everything we need. So we can do it in every crate. So I'll do it in the main crate. Just one simple example. First, we need the switch to the nightly compiler because test SDK needs nightly. Great. Then we need to add the test SDK to the dev dependencies. So, okay. Then we can just write tests. Regarding the thing that were not mentioned, but what I did in the last weeks, it is not the multimodal testing. Multimodal testing we listed several months ago. It is multi-service testing. We can load several services. So let's see at it. We can create several services just by copying the Config.toml and providing different modules there. So let's do it. And so we can delete everything we don't need here, and everything we don't need from here. And we will have like 2 services. So then we can use our running test. We can use it. I don't have the okay to work. So marine test is a macro which wraps a function over the module. Right now I will use it around the function. Let's name a module. It takes several pairs of the modules here and config file, and they are named, so we can access it. We need some time to show it. Okay, we have written the large attributes for this function. Let's write a test function. The marine test macro provides a marine test env module, which holds all the interfaces. Then we can create service. It is a macro, so we don't have any completion here, but I remember anything. This storage, need here storage. So each line of the new of the service interface creates runs new runtime and creates new service. So then we can just do the same that we did in facade model, but in tests, and imagining that serial adapter and storage are different services. So we can call the service the download, like google.com. Then we can we need to mute here because we mutate the internal state. Then we can store we need just to string here because the interface takes string, not the reference of the slice. Then we can read the test file and try to check its content somehow. So let's use first them first path. Okay. Then it will be data dash test file. Okay. Okay. Here we have new. Okay. Then we can read the content of this file. And for example, check if it is not empty. Or check if it equals the result. That is, which is better. You just need to clone here. Then and so then we can run the tests. We can run as usual with cargo test and with release usually because it's has a lot of code independencies and runs much faster in release mode than in.
While we're watching that compile and in the essence of time here, this is obviously really cool.
I cannot show it. In different
I know. But in your words, like, why do you? I mean, you spend all the time. Why is this really, really helpful for developers to be able to do it locally?
It is very helpful because the only way that you can test such thing if you have several services not supposed to be linked in Marine, you can only deploy them to the network and write some Aqua code to compose them. And
right. So now you can do it locally instead of having to deploy everything. Now you only deploy once you've tested locally, and you get the full test locally as you had before only on the network, right?
Yes, that's
a big friggin' deal.
And it can be done automatically.
Yeah.
Also.
Okay. Cool.
And also we team who get used of this feature, and it's when we are developing, there is only one Rust developer in the team, and when he produces something, he can imitate some flows in this approach, and then other developers who can take different decisions what to do with these services in Aqua can write Aqua later, but they are sure that underlayer in Rust is well written, so it allows better split of work between developers than if you write Aqua, because Aqua takes set of different decisions when you implement it. So it's very useful. Yeah.
All right. See, it's still compiling, so we use the time well.
Yeah. Yeah. Right.
Are there any other questions from anybody? Otherwise, Evgeny, you want to wrap it up?
No, because we have also Morgan today to present, and
Oh,
maybe
right.
maybe Evgeny or
Sorry,
you
Morgan.
can tell about the new format that we're talking about right now to everyone.
Yeah. Well, actually, we realized that just right away starting with lectures and getting deep in Fluence is kind of hard for everyone. So we sort of missing also the public updates, like what really happened, like what Fluence Labs team have delivered since last call in last 2 weeks. So we were a little unprepared for today, I guess. So we'll try to make it better next time, like vice versa. I don't know if anyone from Fluence Labs wants to share any updates. Just like do it, and we also should have presentation today. Yeah. And next time we will do vice versa. We'll start from updates, Q&A, some demos, and then like whoever have time and desire to participate in a longer educational session will be able to do it. So
I can share a couple of updates just quickly, and probably I can. Oh no, I will not turn on my video. So in the last 2 weeks, a big part of the Fluence team was in Lisbon. That's not a technical update, but we was in a ETH Lisbon conference and around, and that was pretty cool. And speaking about the deliveries, the main delivery over the last 2 weeks was Aqua.4, and it targets asynchronous JavaScript. It's briefly described in our Telegram channel, but like previously, all the Aqua code on a single peer was executed sequentially, even if you were writing parallel code in the script. And now on the JavaScript side, it's executed in parallel and asynchronous, which is kind of nice. And we are working on doing the same for the node, for the Rust implementation, the Fluence node. And it's on the way. Hopefully we will have it next week, but not sure. And a lot of bug fixes all around, just all around. So that was the quick update.
I just wanted to add a little bit about the asynchronous JavaScript side. Basically, previously you were only able to write synchronous code in the handlers, and now you can use asynchronous code. So if you want to call some API which uses promises under the hood, you can use this API inside your callback.
So we are done and ready for the demos. Or if there are any questions regarding anything in Fluence, they could be asked right now or later, or like.
I guess I had a, can you hear me?
Yes.
Hi, can you hear me?
Yes.
Cool. I just had an initial question regarding, I know that there's some hackathon ongoing with Gitcoin and some other things. Wondering if there's going to be an idea. Like I know that ceramic, there was one with people using ceramic, possibly using IPFS or like textile. I'm wondering if it's going to be automatically out of the box implemented.
By automatically out of the box implemented, you mean like IPFS as a built-in service on the node?
Not necessarily, just some type of, I guess, some type of identity service that's that you can call from the Marine module, or does it always have to be external, in which the person or developer is deciding on which store and keys are getting used?
So right now there are no plans for a generic DID. So it's quote unquote vendor based, right? So we have from the last hackathon, we got the ceramic self ID integrations, and there were a couple submissions that actually did it from Marine as opposed to the front end. So that was pretty cool. But despite DID being a standard, it's really implementation specific. So also on the resolver. So there is no plan right now from us for a generic implementation. But if that's something that's a tooling aspect that's important, we certainly are willing to entertain that build out. So if that's something you're interested in, just contact me on DM me or Anna or whoever.
Okay. Thank you.
So Morgan, did you want to present anything, to demo anything today, or you good? And you mentioned.
Yeah, I had some initial stuff. Everything's kind of a work in progress from the previous ETH Online hackathon, but I've sort of started to strip things down and rebuild sort of an alternative to the existing hack that I was working on. If you would like me to go for it, I will. Basically, I'm coming in more from a higher level perspective from the application point of view, and haven't necessarily focused too much on the Marines and the Aqua side. Fluent pad example, and I've slimmed it down a little bit and built an application surrounding the use of non-invasive brain-computer interfaces into a type of group. I guess I might call it like vibrational rhythm interface. But I have some initial questions and hypotheses that I'm kind of shooting out there to gain some perspective from you guys as to where these technologies from a peer-to-peer perspective might help other domains. So I'll share my screen. Let me know if you can see it. Can you see my screen?
We see that screen has started screen sharing text.
Yeah, but it's black.
Hi, can you still hear me?
Oh, now it's here. Yeah.
Okay, cool. So the project was called Arbor, but there was a few sub models or sub abstractions that I was looking at. One I was calling the fawn lore, and that was the wrapper to the Aqua or just the Fluence network interface. And then the other one was called FogFacts, which is like basically taking the data that I'm sending across this network and compressing it into a type of visualization that would be a possible output for NFTs. So I had certain questions around these technologies. One was, what might peer-to-peer data connections feel like, where data is being sent as particles in a type of ritual social network performing. I read a paper once called Mix Hop, where certain orientations of network neighbors were able to, I guess, collate the way that their identities are formed in a reputation fashion. And by doing a type of mix-up or randomness, there was able to be better results on certain, let's say, intelligent applications. So I'm wondering if there's a solution as it relates to the spectral shapes for communicating with something like, I'm wearing a brain non-invasive brain-computer interface called a Blueberry, which I can go more into later on. But basically, it just takes it uses your blood flow as a proxy for brain activity. So I'm wondering if there's sort of ambient health state, computer-like calmness that we can get to if we're, let's say, finding optimal neighbors that we're vibing with in the same frequency level. And how this perceived randomness from, let's say, cognition can be used for staking something like a biology-like proof of attendance on proposals for cross-DAO communication. So the premise is if you have different DAOs across a network, let's say in using normal blockchains, can Fluence network be the sort of in-between space of which these particles are being sent? And it's cool to hear that there's asynchronous programming in the JavaScript front end to do this, because I was butting heads with my web browser with all these clocks and things running in my example. And then my next question is, where will the active medical and the dreaming neuroeconomies be created with these types of NFT compressions paired with something like an ethereal cognitive study, whether we're talking about metaverse in sort of like virtual worlds or like our real. And my last question is, who will participate in possibly solving the problems of things like carbon life form conservation? So Arbor, as a background, is meant to solve the problem of reforestation with the use of type of portal or interface that is like an alternative reality game that one can use. I won't go into it today, but I will just show the kind of like minimal flow or just the sort of segments that I see with these technologies working together, where we have our collective vibrations, where we're summing our results of our cognition into some type of interface as an NFT. We can possibly map that across some type of geolocation. We'd be getting new shapes of formations from these data particle or wavelets that are being sent across the internet, and can we sort of map these against nature. There was a proposal done by Vitalik talking about cross roll-up NFT wrappers. And I think that there might be some type of solution or question to be solved as it relates to if these NFTs that are being aggregated in these types of radial formations are sort of like true to what we can sort of pass along to each other, let's say from group to group, let's say squad to squad, or like trust network to trust network. Can we also align around some of the other L2 solutions that are being implemented across the different projects to accommodate this, and whether the Fluence network libp2p implementation is being used, or something in other IBC networks, etc. That's sort of how I kind of picture things. Is like we have normal blockchain NFTs as sort of your typical tree structure. Then you have the error interpreter as sort of the intermediate computing representation of these wavelets from some type of cognitive device. So I'm gonna just have a minimal demo for now. Things started to break because I was working with sound on my computer and trying to visualize things. But basically the premise is, if we had, let's say, 4 different people that are connected across the Fluence network, and their data is being sent from their local device across the network and being aggregated at sort of local points, can we get sort of a radial fashion and have that as a NFT output? So again, the example I used was just a slimmed down fork. I basically removed the in-memory history of the messages being stored in the Fluent pad, because I wanted the adapter of using textile as a data storage at sort of the local endpoints, not necessarily across the Fluence network nodes. I think that'll have better capacity as it relates to how many messages can be stored, because I was hitting some barriers with that when I was doing my example. Join the network, and What's timed out for join? Just give it a quick refresh. There's just one extra page. And apologies, I'm in a bit of a not the greatest working environment, but wanted to be here for the community call. Okay, give this another shot. So I go to the next screen and it's asking me to connect a Bluetooth interface. So I'll scroll down to my Blueberry and pair that. Right now it just has online as 0 and it's loading. It has my previous offline users being loaded in. And we should just get a visual where basically the premise is the signal is being sent across the network. I'm performing an FFT on these windows of information, which I'm then aggregating. And you see in the bottom here, some data that's being accumulated from my cognition. And then this part has broken for time being, but I would click and I would have some type of audio signal maybe mapped on something that actually sounds much better and not so annoying. But the premise is to sort of get like a genetic dial-up for what a cross-internet, genetic dial-up is kind of like the coin or the term I'm using for the time being. But you get this radial fashion where the higher frequencies at the center, the lower frequencies are at the outset, and it would play a sort of tune, and that would be sort of a NFT output from this. So that's my presentation. I just want to say, thank you so much for all the incredible work that your team is doing. I find it really cool. And so far, I hope that there's some additional questions that may be posed to the team as it relates to some of the use cases in the sort of possibly medical domain that I think that this technology might be applicable to. So thank you very much. Stop sharing my screen.
Wow. That's really amazing. I mean, that's super great concept. And it's really worked. I like that it's really worked. Like we heard the sound. It was like a little hard to hear because of noise cancellation that probably Zoom enables. But yeah, that's super cool. So
I did have it working where it was like fluctuating based on the some notes. Cool.
Oh, I guess maybe it's my connection or not my connection. Based on what?
Lost you. Probably my connection.
Can you guys hear
me
more?
now?
Not really.
Yeah, I can hear.
Well, I'm open to any questions if you can still hear me. If not, I can just connect on the Telegram group. Really thankful to have that available to the developers.
Well, actually, the only thing I was thinking of is this shows kind of the this is like a great, looks like a great product, and it shows like the wide sort of variety of use cases that could be achieved with peer-to-peer technology. And it's like, I mean, I like that a lot, because like usually we think about something, that see kind of like peer-to-peer messengers, or like something connected to like the DAOs and stuff. And this is kind of like the whole new angle of thinking about peer-to-peer. So I love the concept. I hope that you will continue working on this, and Fluence would be like the great fundamental for this product.
Yes, I definitely plan to continue. And I'd like to see how it might implement other or impact other projects across the Web3 space.
Amazing. So anyone have any questions, comments, ideas?
I have one question for Morgan, and it's about Fluence. And it's about like, why does this Fluence network is the right solution for you now for your project? Like you probably been looking at, I had a look at your GitHub today because we had a communication, and I saw you experimented also with other like networks. So why did you choose to work with the Fluence now?
Yeah, so I was, I guess this kind of started maybe 2 years ago, just experimenting with these maybe you might call it art, I'm not sure, concepts. I started using something in the domain of hyperswarm or hypercores as sort of thinking about data as like, if I'm owning my own data, it's like local storage to my own device. So I have local storage, and then I have access to global storage, something like IPFS. Then when I heard about Fluence, I really liked the fact that I could adjust the network topology in an easy to use way with their additional virtual machine. So that was kind of attractive to me, and the fact that it's a sidecar to normal IPFS. So that was a big benefit. I could, storing data within these scripts, I can retrieve them and I can do like a compute value in a decentralized way. And that was really attractive if I'm doing like, let's say, some type of data flow counter for to say like, if I'm meditating with this data flow in a peer-to-peer way, I can compute how much like for my example is basically I want to get to a per kilobyte or per megabyte, how many trees can we plant if I'm donating data and have the connection to actual smart contracts in, let's say, the Ethereum blockchain. So that was sort of other considerations. And then the final project that might be exploring in the future, I need to wrap my head around it, is possibly using Urbit's network as a communication protocol. But then that has some limitations, and I mean, I'm no expert, so I'm really just a curious developer wanting to learn these different toolings, and so far it meets the standard that I'm looking for. But I'd be curious to know if there was things that you saw or things that you might recommend that I look into.
I'm not.
Yeah, basically topology and connection to blockchain are kind of big ones. IPFS.
Would it be fair to say that Fluence is in a way very programmable, because we have very different use cases, and I found it also interesting because it's certain like programmable in a way that I can just do with it what I want to do, and that's maybe a compliment to the team, that it's rather open, and very different sort of people can come for different use cases and try to see if it can work.
Yeah, and I think that there was some statement saying that it's non-Turing complete. If I heard correctly, is that true? Can someone from the team maybe comment?
Are you asking about not Turing completeness of air?
Yeah.
Well, it slightly moves towards being Turing complete, but we haven't checked. So it was designed as not Turing complete, but as it evolves, it might finally be Turing complete. So I'm not sure, to be honest.
Okay, no problem. I'm again no expert. I'm just sort of full stack developer here, but I know that questions of our cognition are very very broad. So it's like maybe mapping the development of Fluence alongside the development of types of neuroscience might be kind of an interesting path, but I won't comment. Thank you.
Morgan, can I ask, how did you turn into Web3 space? Like, what triggered you, just out of curiosity?
Yeah, I guess like I was really into the culture of the hackathons, whether in person or remote. That was a big one for me, and the impact that it had on some of the global values of you know, implementing, let's say, financial transactions in a open, transparent, or even privacy driven way. Some of these values are really true to me. You know, censorship can be an issue here and there, but I find that some of the goals that at least I'm focusing on right now as it relates to sustainability and some of the problems in the medical domain are really fascinating me. But definitely what drove me into the space was the Ethereum hackathons and sort of the benefits that we get from having this sort of global open financial network, and you know, removing the middleman can be a huge positive with creating the types of efficiencies and reallocation of resources that we might strive for you know, the type of abundance we seek. So it's not really that direct of a question, but I guess it's been a long bit of a path. But I came more from the centralized corporate domain, building sort of off MVP projects, and I just find the fast iteration, experimentation to be really attractive from a personal development perspective, and then from a global perspective, those other goals that I mentioned.
Cool, thank you so much. That's very interesting.
No problem.
Cool. Also on Fluence value, Fluence is super valuable because it allows to compose all the things together. Like if you would want to use, like to combine off-chain peer-to-peer protocol of Morgan with the protocol of Joera, then it's possible to do with Fluence because it's kind of designed this way. So this is the one of the biggest value that people not yet fully understand, because there is not much things yet built on Fluence, but it will be more and more clear. It's kind of same composability that you have on chain, but off chain in the particular protocols, which is cool.
And maybe the word I was looking for before was like unopinionated, in the sense that you do not think that much of a use case, or at least that I'm not aware of it, which is a good thing, because it just attracts people that want to imagine their own use cases.
Yeah. So basically,
it's the same sense why Ethereum is becoming the biggest blockchain, because they didn't think of what it should have been, or how people should use it.
Yeah, exactly. I love this point. I love this point, and I think it's basically the power of the power of community that explores all set of use cases is much higher than, like, you know, when the team, like the founding team decides, okay, like this will be, you know, the blockchain for this or the blockchain for that. So this great approach, I think we want to sort of try to repeat this with Fluence, to be unopinionated as much as we can, and allow people to, you know, be creative and build very different kind of things, and then figure out composition of them and so on and so forth, because it's all kind of doesn't depend on any central entity or nodes or like a global consensus or something like that. All right. Should you wrap up then? Thank you, everyone. Thank you, Valery, for the great presentation and the deep dive to Marine. That was amazing. Thank you, Morgan, for this very unusual product presentation. So very nice. I love it. Yeah, thank you. Thank you, everyone.
Thank you, Morgan. Thank you, everyone.
All right. See you in 2 weeks. Bye-bye.
See you.
Bye.
Bye.